with the container-based action routing tool, or CART, which is about providing efficient routes and schedules for delivery and collection operations. I'm going to hand it over to the two volunteers, Seb and Andre, who I believe are here. You can go ahead and take yourself off mute and turn on your video and take it away.
Hi, my name is Seb. I've been working on this for a few years now.
Hi, and my name is Andre. I've been on the project for about a year now. I think I started last year March on the project. Maybe just a bit of the project. The project is the container-based action routing tool, or CART for short. That is a routing tool that we've built for clients. If you can maybe move on to the next slide, or is there a way that I can move on to the next slide? Thank you. So yes, the problem is we have multiple non-profits that is developing sustainable sanitation solutions in densely populated areas where there is no sanitation infrastructure in the cities. So the way they do it is they are basically collecting the sanitation waste in containers, and then these container wastes need to go to a processing plant. I think most of the partners are making fertilizer out of those waste, or at least just process it that it is non-hazardous and non-toxic to the environment. So DataKind first partnered with Soil in Haiti in 2019 to develop a route optimization tool for them and a mapping application to map their collection points and can give more analytics to the people that need to do the planning. DataKind also then partnered with Sanima in Peru and Synergy in Kenya last year. And the tool was then rebranded to CART, and the goal of the tool was then to make it generic so that multiple partners can use the same tool for their routing needs. I think Sebastian will touch on it later, but we also moved out of just the sanitation space with the routing tool, so there are other clients that is also looking into using this tool. So first off, what is a routing tool? A routing tool is software that basically finds an optimal way to assign pickups and deliveries to a transportation fleet in an optimal manner. It can be optimized on travel distance, on cost, on time, or in a lot of cases on combinations of these objectives. So, but when we do that, we also have constraints that we need to take into account, like customer time windows. Customers like to know you're gonna pick up the package or deliver it in a certain time frame. If you can't give them a certain time frame, they need to wait for you basically the whole day, and that is not efficient. We also have route constraints. Some roads are highways where you can have high speed limits. Some roads are basically footpaths where you actually can't travel with a vehicle at all. So we need to take that into account. And then we also have vehicle capacities. Are you on a motorcycle? Are you in a big truck? And that determines how many assignments you can do to a certain vehicle in the fleet. So to solve these types of problems, we need information about our pickup locations, the drop-off locations, and then also the route network. We need a location where we need to pick it up, when we can pick it up. We have other constraints, like some vehicles can't reach certain locations, but other vehicles can, so we need to assign the correct vehicle to do the pickup or the drop off. The vehicles can also maybe travel at different speeds. We need to take that into account. And then the route network, as I've said before, it also has speed limits, speed constraints, vehicle type constraints, and that type of thing.
Right.
And
So
here I'm going to hand over to Sebastian.
thank you. So some of the things we've done recently, because this has been ongoing for a few years, where some what I'll call solution improvements, like this one, as well as some usability improvements. So the first one here was the challenge of elevation. What happens generally with loaded vehicles, they become heavier and or lighter, depending on how you're collecting or delivering. And some roads, even with a very light vehicle, may not be suitable given the steepness of the road. So this wasn't such an issue in the first area we worked on, but when we started talking to Sanima in Peru, Lima is a very mountainous area, so this became a larger concern. And one approach we started for this challenge was introducing open topography DEM data, so digital elevation models, and calculating the incline essentially between areas of the network over there. So this is actually not Peru. What we are seeing here is a few kilometers of Nairobi in Kenya. And because there's also an area where some more steep roads can produce suboptimal solutions, and we're looking at that for essentially any open source data in terms of elevation. So OpenTopography is a great resource for this. The next improvement was really about how to make this a more adopted open source tool. So the first time when we worked with Soil Haiti, this was a solution tailored to really what they were doing in terms of data integration, in terms of usability. So here we develop an API endpoint server, so we can easily have data that's more flexible. And we also have an integration with OSMand, which is essentially Google Maps. So you have a turn-by-turn navigation. You can import a track that you can follow. And we also have a graphics user interface now. So the next slide, we have a video that we can play very quickly, if that works. I'm not sure if it will actually show, but it will. Okay, it seems like it works. Thanks. So this is essentially the data we need, so a JSON and a CSV or an Excel spreadsheet. And we build this in Streamlit. So you can drop in your files, choose what you want to update in terms of the different files you need, and calculate the routes. And then you'll see the map appearing in the web interface, as well as the solution. And this is essentially just in real time. So for small maps, small amount of customers can be very fast. It's also very controllable. So if you want a better solution, you can let it run for longer. But this was essentially an optimal solution done very quickly for only 60 locations. Some of our partner organizations, they have upwards of 800 locations to visit given a single day. So yeah, so this is it for the demonstration, essentially the improvements. On the next slide, we have some more info about really what we output. The idea is essentially we want to produce files that can be usable in various systems. Again, we made some efforts in terms of making it accessible and open source so people can then develop their own solutions on top of it, because some partner organization may have their own applications where they say, let's give us just a series of which locations to visit in the correct order, and then we'll do navigation, or we want the whole navigation, or we want to integrate with something like TaroWorks or OSMand. So having those multiple types of outputs is very important. And finally, you'll see again, some more details in the next slide of what's the output. If you are interested, you can try it out or contribute at this URL, or you can search for DataKind, cart, or etc. So that's it for us. Thank you all.
Thank you so much. And I feel like I need this because it's like I have to pick this cut up here and drop this cut up here and pick this up at the store and go to that pharmacy. So like I kind of want this for my personal life.